single LED bulb costs only a few dollars, but with 15 billion units made yearly, it's a $100 billion industry.
The journey starts with sapphire substrates, the foundation of every LED chip, handled at a massive industrial scale. Mass production. Humans must enter an environment of absolute cleanliness, where air showers strip away every speck of dust.
Inside epitaxial chambers, gallium and nitrogen gases bond atom by atom at extreme industrial temperatures.
Industrial scale, these layers form the p-n junction, the exact spot where electricity transforms into light.
Once the epitaxial growth is finished, the wafer looks like a mirror, but it actually holds millions of invisible light structures.
In a controlled yellow light zone, the wafer is coated with light-sensitive photoresist at high speed.
Photolithography uses UV light to draw microscopic circuits on thousands of chips simultaneously. Metal deposition in a vacuum creates electrical contacts, turning the wafer into a massive light circuit board.
Industrial scale production requires kilometers of pure gold wire, thinner than a human hair.
Now the wafer is a microscopic map of tens of thousands of identical LED chips, waiting to be separated.
High-energy lasers slice along pre-calculated lines to separate thousands of tiny square dies. Each chip is briefly powered to verify color and voltage. Mass production leaves no room for defects.
Crystal expanders apply uniform tension to the film, spacing chips out for high-speed robotic pickup.
Die bonding machines dispense thermally conductive adhesive onto metal lead frames with micrometer accuracy.
The robotic arm operates at near instantaneous speed. Pick, rotate, and place, taking only fractions of a millisecond.
The lead frames are transferred into thermal ovens to permanently lock each chip into its unified structure.
Using heat and ultrasonic energy, gold wires are bonded to the chip's electrodes at an industrial pace.
Mass production of billions of units requires rows of machines working 24/7 with uncompromising precision.
Phosphor powder is weighed with accuracy down to a 10,000th of a gram for perfect color.
The secret is that no chip naturally emits white light. It's this yellow phosphor coating that converts blue light to white.
High-speed industrial mixers ensure the phosphor is perfectly dispersed within the epoxy solution.
Dispensing needles deposit the mixture accurate to millionths of a liter onto every individual LED.
Thermal curing at 302 degrees Fahrenheit hardens the epoxy, locking the phosphor layer forever. Industrial molding machines inject liquid resin to create the LED's signature transparent lens.
The lens protects the internal wires and determines the light beam's shape. Now they are almost finished. And
Under controlled heat, the epoxy solidifies into a crystal clear structure, protecting the delicate chip. Deframing machines cut the metal links, releasing individual LED packages at incredible speeds.
Mass production allows for thousands of units to be separated and moved to testing in seconds.
Automated electro-optical testers measure brightness and color output faster than the eye can see.
Each LED is sorted into bins based on color and voltage to ensure perfectly uniform light in the final product.
Pneumatic mechanisms direct every LED into its corresponding compartment with high-speed air pulses. Lead-forming machines shape the metal terminals, preparing them for the next stage of assembly.
To maintain quality, billions of LEDs are sealed in anti-static, moisture-resistant industrial packaging.
Massive labeling systems track every batch, ensuring the industrial world gets the exact specs needed.
These finished shipments are sent worldwide to factories making everything from toys to streetlights.
Industrial logistics ensure that millions of components reach downstream assembly plants daily. In final assembly, LEDs are mounted onto strips or panels at a speed of thousands per hour. Industrial-scale soldering creates permanent electrical bonds for long-term durability.
Massive assembly of bulb housings involves robotic arms snapping components together with force.
This simple bulb is the result of thousands of precision-engineered industrial steps.
Final assembly machines press-fit the frosted domes to finish the aesthetic of the bulb.
High-speed laser marking identifies technical specs for consumers at an industrial scale.
Every bulb is tested for its total light output, ensuring the industrial standard is met.
Packaging lines fold and fill thousands of retail boxes every hour for global distribution.
From this facility, billions of sources of light are ready to brighten every corner of the planet.
Industrial-scale shrink wrapping secures the product for its journey across oceans and continents.
Global deployment. Billions of LEDs are transported by sea and air to reach every market.
Modern infrastructure relies on the mass production of these highly efficient light sources.
The industrial world operates on LEDs, from tiny indicators to massive displays.
Final reliability checks ensure mass-produced units can survive any real-world environment.
LEDs provide cleaner, cooler, and far more durable light than any technology before them. New product launches bring the latest semiconductor breakthroughs to the mass market. The light meter is reading well over 80,000 lux at this distance. Absolutely stunning output.
Mass distribution networks ensure that LEDs are available in every local community.
The market shift to LED has saved billions of dollars in energy costs worldwide.
This is the triumph of industrial engineering, transforming a speck of dust into global light.
Deployment at scale. The final leg of the journey from factory to the consumer's home.
I can't believe they finally turned it on. It's stunning.
The global deployment of LED technology is so vast, it is visible from outer space.
The industry continues to thrive as manufacturing reaches even higher industrial scales.
Industrial responsibility means planning for the end of the product life cycle at scale.
From a microscopic chip to a brighter world. That's how billions of LEDs are made.
Subscribe to Process Next for more deep dives into the industrial world's secrets.